Suppose you want to determine whether the mean content of super cola cans is less than 12 ounces. This type of inference is called the test of hypothesis. Hypothesis tests are analogous to the system of trial by jury. In our example, the super cola cans are the accused. The researchers are the prosecution. The data that we collect is the evidence. The claim that the mean content of super cola cans is less than 12 ounces is the charges against the accused. And in a trial by jury, charges are assumed to be not true. And in a hypothesis test, we assume that the claim is not true. And in the trial by jury, we assume that the charges are not true until proven otherwise beyond reasonable doubt. And in our hypothesis test, we are going to keep assuming that the claim is not true until we have sufficient evidence to the contrary. So we are going to explain all of these elements in detail now. So let's say that we take a sample of 50 super cola cans. We measure the mean content, and it was 11.7. So this seems to be in favor of the claim. Okay, and the standard deviation was 1. The claim is what we are going to call the alternative hypothesis, which is that the mean is less than 12. And what we are going to assume is what we will call the null hypothesis, HO, which is supposed to be the negation of this, right? And the negation of this would be that the mean is greater than or equal than 12. Some books will say it this way, but you will see that other books are going to say equal. The reason to use equal is that we need one value of the mean that we are going to use when we do our calculations. So this doesn't represent one value. This represents a range of values. So our job is now to see if this data constitutes sufficient evidence to prove that our assumption is not true, and therefore we are going to conclude the claim. Now, you probably remember from the central limit theorem that if the mean of the distribution of our random variable x is mu, the mean of the sampling distribution, that means the mean of the distribution of all sample means, is also mu. So we are going to do our hypothesis test not specifying HO this way, but always equal, because we need one value, that value. That is a value that we are going to assume to be true. And assuming that the mean is 12, the population mean is 12, and we saw here that the sample mean was 11.7, we would like to find out how far is this sample mean from mu in terms of standard deviations. In other words, what we want to do is find out the z-score of this sample mean. We have done this type of thing before. How do we calculate the z-score? Originally, you saw that the z-score was x minus mu over sigma. But be careful, because we are working with this distribution, and instead of sigma, we have sigma divided by the square root of n. Okay, so it shouldn't be divided by sigma. and shouldn't be x because this is not x, this is x bar. So now the way that we calculate the z-score is not this way, okay? We're going to say the z-score is x bar minus mu divided by sigma divided by the square root of n. So this is going to give us the z-score right here. This is what we're going to call the test statistic. And the value of mu that we assume true, we are going to call it mu sub 0. Okay, so plugging the values, x bar is 11.7. Mu sub 0 is the mean. Sigma is 1. And n is 50. When you do these calculations with your calculator, it is very useful if your calculator has this fraction key. Avoids lots of errors. 11.7 minus 12, and then in the denominator I need another fraction, so I hit that key again. And then 1 on the numerator with the arrow I move down, and then square root of 50, and we get our answer, which is negative 2.12. Negative 2.12. And this area that I have shaded here represents the probability of getting a z-score this far from the mean or farther. In other words, it is a probability of getting a sample mean this far from the mean or farther, assuming that mu sub 0 is 12. Okay, so let's calculate that p-value. Now remember that the standard normal distribution, any normal distribution, is symmetric with respect to the mean. So if this is negative 2.12, this is 2.12, and if this is a p-value, this area is also the p-value. The table that I normally use gives me the areas between 0 and whatever z-score I'm using. The z-score that we're using is 2.12, so I get 0.483. That is this area here. And then this area here is going to be 0.5, which is all the area from here to infinity, right? 0.5 minus 0.4830. That is the p-value. And that is the probability of getting a sample mean of 11.7 or farther to the left, assuming that mu sub 0 is 12. And that is a very small probability. It's a very unlikely event. So what is the statistician going to conclude? That the mean of the population is 12 and that was a very unlikely event? No. The statistician is going to say, no, we are going to reject the null hypothesis that the mean is 12 and conclude that it has to be less than 12. In other words, we reject HO and conclude HA. Reject HO and conclude HA. Now, the problem is, what are we going to consider too low? Okay, in this case, we said, well, that was very small probability, but where do we draw the line? When the p-value is less than what? We are going to say that we reject HO and conclude HA. And what researchers normally use is 0.05, which we call alpha. And the decision rule is, if the p-value is less than alpha, then reject HO and conclude HA. And our conclusion is that the data provides sufficient evidence to conclude that all super cola cans have a mean content less than 12 ounces. Summarizing, this is all the steps you have to do to do a hypothesis test. First, set up HO and HA. Second, test statistic. Step 3, calculate the p-value. Step 4, write your decision whether to reject HO or not reject HO. And step number 5, your conclusion, which should be stated in plain English. Don't mention anything like HO or HA or anything like that. Plain English. I forgot to mention in the conclusion, at the end of the conclusion, you should add alpha equals 0.05. There is another way to do hypothesis testing, which is using rejection regions instead of p-values, but that will be explained in another video.